Welcome back, everybody. This is our second video on numerical integration. In the first video, we discussed why in the world we want to do numerical integration in the first place, and we found our first numerical integration technique, namely left endpoint approximation method. In this video, we're going to start off with a right endpoint approximation method, which is pretty much the same thing, but on the right. And then we'll get to one which is a little more interesting called the midpoint rule. And this is going to, you guessed it, use not the left or the right, but the midpoint. Okay, it's just like it sounds. Let's give it a look-see here. So first, we want to do a right endpoint approximation. So when we do a right endpoint approximation, we're going to take our graph, we're going to subdivide into intervals again. We'll look at this first interval, x0 to x1, and we're going to sample the function not at x0, right? Last time, remember, the left endpoint was x0, so we sampled the function at x0. We're going to sample the function instead at x1. So I say, okay, how far up do I have to go? Okay, there's my y sub 1. And so my area, well, the first thing I'm going to do is, well, I guess I should fill in this rectangle here. So this has area, this blue region. And you remember before we said we're going to actually keep these all the same length. So we'll put those back in. There's a delta x and a delta x and a delta x. And so I know that the base of each of these is going to be delta x. All right. And so all I'm going to have to do is add up the heights. And so what are the heights going to be? Well, this first one, it was y1. Okay, now I move over and I do the second one. There's my base. I look at f at x2, so I sample it at x2. Okay, there's my y2. I build a rectangle with that appropriate height. Okay, so there's my next area. The base, still delta x, the height, y2. So I just add a delta x times y2. And then finally, I do the x2 to x3 interval. And so, okay, I'm sampling where? At x3. So there's my height now. That's my y3. So I get this teeny little rectangle, which is clearly missing a whole bunch of area from there. But that's okay, just an approximation. And so the area of this rectangle, delta x, times the height, which is y3. So I get a plus y3. Now, if you look at the left endpoint approximation formula, it looked very, very similar. Delta x times, well, it's just shifted. Before it was y0 plus y1 plus y2. You just took the ones corresponding to the first three. When we do the right endpoint approximation, you just take the ones corresponding to the last three. Those are the right endpoints of those rectangles. So that's not too bad. All right? So in general, you're not really expecting the left endpoint or the right endpoint to be significantly better than the other one in general. Right? What you expect is that for a specific type of function, one of them may be closer than another one. Okay. So it turns out in practice, neither the left endpoint or the right endpoint is going to be as good as some other techniques. And so since, well, it's always good to find some balance, we look at the midpoint formula now. The midpoint formula, we're going to not use the left or the right, but a point smack dab in the middle. Let me clean this up a little bit and we'll get to it. All right, so in this section of the video, we're going to learn about what is often called the midpoint rule. So this is a middle ground approximation between the left endpoint and the right endpoint rules. It's very obvious at how we're going to choose our point. Instead of sampling our function, say we're looking at the first interval, x0 to x1. So say instead of sampling at x0 or sampling at x1, we're going to sample at a point smack dab in the middle. Yeah, we expect maybe that's, it's not going to be too high or too low. It'll be kind of Goldilocks, just right. So I'm going to give a name to this point in the middle. And by convention, we're going to use the right endpoint to index it. Only we can't just call it x1. We put a little bar over it. So where are we getting this bar from? Well, in statistics, when you put a bar over something, it means you're taking an average. So that's where this notation is coming from. The midpoint between x0 and x1 is the average of x0 and x1. So I'm going to sample the function at the point x1 bar. And that's going to give me now a height that I can extend across to x0 and across to x1. And it gives me this new rectangle, which you can see is a little bit high on this side and a little bit low over here, but in general actually pretty good. All right, so let's write down an area approximation formula. So first, what's the width of this rectangle? Well, the rectangle still has a base from x0 to x1. We're still assuming that it's always the same width, so it's still delta x. Whoop. A is for atom, but we want a delta. So we have a delta x, and what's the height? Well, the height is this value, which we'll call y1 bar. So this is the value of f at x1 bar. So we'll write y1 bar. Okay, now we move over. We go to x1 to x2. We want to do that. Fine, I take the midpoint, x2 bar, and I'm going to sample the function at x2 bar. Okay, what's the value at that point? Well, again, that's what we call y2 bar. And now I draw a rectangle with the appropriate height. Okay, we'll get a little color in. Okay, so there's my second rectangle. Again, the base is delta x. That's no different. The height now, though, is the y2 bar. Okay, and finally we do the x2 to x3 interval. Find the midpoint, that's x3 bar. Sample the function. Okay, goes about there. That gives us a height. That's our y3 bar. And we'll fill this out to make a nice rectangle. Color it in. And now I have a third rectangle. Base, again, delta x. Height is going to be the y3 bar. Okay, so the midpoint rule looks very much like the left and the right endpoint ones. You have this delta x term, and you're going to multiply by a sum of 3 y values, okay? Or in general, n y values, depending on how many points you take here. Looks pretty much the same. Turns out midpoint rule generally going to be way more accurate than the left endpoint or the right endpoint rule. So it's a good way to go. Okay, so we're going to take a break here. Next video, we're going to come back and do one more rule. See, if you're looking at this, you might think there could be another way of combining the left and the right instead of looking at the midpoint. Maybe there's some other way. And there is, and it's going to be called the Trapezoidal Rule. So we'll show you how that works. And then we'll work through an example that uses the left endpoint, the right endpoint, the midpoint, and the trapezoidal rules. Kind of compare them, see who's getting closer to the correct answer. All right, we'll see you next time.